I'm quite honored to be included in this very prestigious group of colleagues. So thank you to Natalie and the Nature team and Andrew for including me in this presentation. I've been asked to give a little bit of information on cell culture systems for iPS cells and ES cells, but I want to provide you a little bit of information about WiCell to start with, since they actually paid for my plane ticket, so I have to say a little something about my organization. For those of you who are unfamiliar with WiCell, we are a small nonprofit organization based out of Madison, Wisconsin, which is in the northern central part of the United States. We're primarily known for our HES cell banking, HPS cell banking. We have more than 1,350 cell lines that are available to researchers around the globe. Our primary mission at this point is that of a service organization to provide support and materials to the stem cell culture community as they work towards improving conditions for the human. We've made more than 6,000 distributions to date to over 600 laboratories in 45 countries. Our characterization services are offered as well. Our board-certified cytogenetics group has performed more than 10,000 karyotypes to date. We also provide services like STR, pluripotency testing through teratomas, and other types of characterization. We perform contract cell banking for cell lines that are being distributed both through our bank and not through our bank. We'll provide them to other banks for distribution. We've worked with groups like the Michael J. Fox Foundation to make their Parkinson's cell lines available in Massachusetts General Hospital as well. We also do reagent testing. We'll beta test products for commercial companies prior to their release and have worked for groups like Corning and Biological Industries and others. When we talk about in vitro culture systems for maintaining pluripotency, I think the first thing we have to do is define our culture system, or define what it means to talk about a culture system. And most times when I look at the literature, culture systems are primarily defined by medium and substrate. It's important to remember that an entire culture system includes much more than that, and should at a minimum include information on the passaging strategy and the environment that the cells were grown in. So looking at medium over the last 20 years, we've seen a progression from serum-based media that relied on direct co-culture into feeder-free systems, which still relied on products secreted by the MEFs into a conditioned medium, to feeder-independent medium, like teaser or E8, which don't rely on any sort of feeder layers at all. We've progressed from animal-based components through xeno-free. We're progressed into cell lines or cell media that are more GMP dependent. A number of additives have been seen coming and going through the years, which primarily would include things like FGF, but could include things like Rho kinase inhibitors, activin A, Wnt, even N2B27 in some of the 2I media. And when you talk about medium for culture system, you also have to talk about how the medium is provided, whether the cells are fed daily or whether they're used more of a flex feed system. Substrates, we've also seen progression through, beginning with direct co-culture on feeders into combined ECM proteins in products like Matrigel and other sorts of similar derivatives, to human-sourced individual ECM proteins, to recombinant proteins, moving more towards xeno-free products. There are also other sorts of substrates that have been used, including just serum coating or gelatin coating, to various levels of success. Passaging strategy, beginning with collagenase or dispase or mechanical types of dissociation, whether or not you include a spin when you do, or a rinse when you're doing sorts of dissociation methods, progressing through things like enzymatic. Collagenase and dispase would be enzymatic. More non-enzymatic would be calcium magnesium for PBS, EDTA. Looking at single cell passaging or clump passaging is important to identify when you're talking about these culture systems, and also whether you're passaging the cells on demand or on a schedule, and all of that would be important. Environment would include things like the gas atmosphere, pH, humidity, temperature, osmolarity, and as we get more and more involved in bioengineering, things like strain, shear, and pressure, and other types of things that the cells are subjected to in culture. So if you take all of these things together, that would define the culture system. We've seen a tremendous evolution of culture systems through the years. In 1998, I'm going to call it a standard. The original conditions that the cells were derived in Jamie's lab included del-bucose modified Eagles medium, a very simple balanced salt solution, supplemented with serum, basic FGF, glutamine, beta-mercaptor ethanol, directly co-cultured on murine MEFs, 80% humidified atmosphere of 5% CO2 in air, mechanical passaging in clumps on demand. So if you look at the entire progression of cell cultures, when we get to the 2018 standard, yeah, no standard. Doesn't exist at this point, and it's clear that it probably can't exist because the types of medias that are used and the types of strategies that are used are going to be very lab dependent and very project dependent. On where you want to go is going to dictate how you're getting there, and what you need to do in the cells during culture to manipulate them is going to be important as well. Now, at WiCell, we have an opportunity to see the culture systems that are primarily used in the wild. Because we are distributing more than 1,350 cell lines, and WiCell itself owns none of the cell lines that it distributes, we have an opportunity to look at how the cell lines are cultured within the provider's hands as they come into WiCell being cultured in their laboratory. So we can identify the most common culture systems that are used in the cell lines that are being deposited and distributed through us. And by far, the most common culture system we see is what we shorthandedly call the teaser matrigel system, even after I just told you you shouldn't describe it by just median matrix. This system includes mTeaser1, matrigel, and a humidified atmosphere of CO2 and air, passage with EDTAs in clumps on demand. Fully 65% of the cell lines that we receive have been cultured this way prior to deposit. The next most popular culture system is E8 vitronectin, followed by not followed by E8 matrigel, but E8 on matrigel makes up 7%. So 18% on E8 vitronectin, 7% on E8 matrigel, which I always found very interesting because in my mind, the point of using E8 is that it's a completely humanized system. And then you slap it on pureed mouse tumor. So I don't quite understand that, but it's probably due to cost-effective nature of the culture system. Cultured in humidified atmosphere of 5% CO2 air, also passaged with EDTA in clumps on demand. And finally, we do see a culture system that was originally published as hESC culture media, but is used not only for ESCs, but hPSCs as well. DMEMF12 media supplemented with knockout serum replacer, basic FGF glutamine BME, with lots of similar parameters as the other two systems. The MEF ratio varies dramatically from laboratory to laboratory, and there seems to be not a lot of consistency in that. And the passaging system tends to be enzymatic, but it can include collagenase as well as dispase. So if you do the quick math, that totals 100%, but there's some rounding in there. We do have less than 1% of our cells are deposited on other culture systems, but only less than 1%. So there are a few exotic systems out there. 0.25% are deposited using conditioned media on matrigel. There are a few other more exotic systems that are used, but this primarily is what we're seeing these days. So where do we go from here? How do you move towards the ideal culture system? And again, that's going to depend on what you're doing, where you want to go, and how you have to manipulate the cells in culture to achieve your goal. But as I'm out talking to researchers at different meetings and evaluating the systems that are coming up, there are certain criteria that seem to arise within the scientific community when you talk about what do people want, where do we want to go. So I don't know where we're going, but these are the things that people are talking about. First of all, cost effective. Anything that we're going to move to as a community, this is a primary issue within the culture system. Now, as you're going more towards clinical trial, the cost issue becomes less concerning, but for the basic laboratory, this is still a general area of concern. Ease of use, simple to use, and this makes sense. We all want it cheap and easy. Defined or described, so that, or at least able to be defined and described to the user at some point, so that those who are working with the media are aware of what's in the media and how those components may affect the research they're doing. Scalable, able to work in a small research laboratory, but as we move towards larger projects, able to scale with the project to avoid having to do crossover studies as you're switching media to something that's more clinically compatible. GMP compatible, obviously, as we move forward. And there has been, more recently, a significant increase in concerns about promoting stability and how media can affect that. So given that, there are a few trends that have been emerging recently over the last few years, including, first of all, flexible feeding media. There are a variety of them out on the market that are either whole media that can be used for flexible feeding or media components like beads that can be added. The primary mechanism of this is that they utilize a stabilized or slow-release FGF, which allows feeding fewer times a week and splitting on a schedule. So advantages obviously would be scheduling and the cost. If you're feeding less frequently, you're feeding less media, and it's probably costing you less. But there are some concerns to be aware of. The first is looking at the FGF being the primary mechanism, the assumption is that's the only thing that's necessary to consider if you're going to not change the media daily, and that's just something to be careful of. In my opinion, you have to flush that toilet on a regular basis too. You're building up waste within the system, which is going to acidify the culture. Work that we did in developing the teaser media in 2006 showed quite clearly that as you acidify the media, you make sacrifices in cell proliferation. So while the cells do survive and survive well, they may not necessarily be as optimal depending on how you are growing the cells in your laboratory. Also, Claudia Spitz published work in 2016 that very clearly showed that as the lactic acid release from the cells acidifies the culture, it's a direct cause of genetics instability within the culture. Single-cell passaging as well has received a lot of attention lately, and many culture systems are moving towards single-cell passaging. Advantages, again, are the ease. It's easy to consistently individualize cells, where if you're clump passaging, consistently getting a standard size of clumps has a little more art to it. Also, single-cell passaging can be required when you're having to do manipulations to the cell line. For the work that we do in the stem cell bank, we don't recommend single-cell passaging unless you are required to individualize the cells for working. The primary concern here is long-term stability. As you individualize the cells, this cloning efficiency of a normal pluripotent stem cell is quite low, less than 1%. As you develop potential mutations within the cell line, those abnormal cells can have a much higher cloning efficiency, meaning that as you individualize those cells and plate them down, there's a potential for them to outpace in growth the normal cell lines and drive your cell line towards an abnormal culture system, or towards an abnormal culture within the system. So it's important, if you're going to be individually passaging your cells as single cells, that you continue to monitor the karyotype of the cell lines to assure that you're maintaining a normal karyotype. So in summary, culture medium and substrate is culture medium is more than just medium and substrate, and as we are reporting that within the literature, we should be including all the aspects of the culture system so that those evaluating the manuscript can have a full picture of how the cells were handled. There is no current standard culture system for human pluripotent stem cells, and the ideal culture system may be situation dependent. And finally, long-term stability is affected by multiple parameters, and culture trends should be very carefully evaluated with this in mind. Just a little snapshot of our little group out in Wisconsin. This is for the UW, not for WiCell, but there you go. And I want to particularly acknowledge Jenny Brame, who is on the bottom row on the far end and has been with me for the last 16 years as my lead technician and laboratory manager, and has her hands on everything I've ever touched. So.
Your data on the repartition of medium are based on the banking you've done, but I would have thought that E8 was much more broadly used now. Because I have the feeling that over the years, especially the 3-4 past years, there's been a massive switch to those culture conditions. And do you think that maybe your data are based on banking, so previous method, and let's take time just to switch, or and that may not reflect the current tendency on live?
Yeah, it's hard to say. Obviously, we're seeing a slice, so we're seeing what's being deposited with us and not necessarily what's being grown everywhere. My gut feeling is that it's fairly representative, but I can't prove it. 1,250 of our cell lines have been deposited within the last 2 years, and the bulk of those came on teaser matrigel. We are seeing more being deposited on E8 vitronectin or E8 matrigel, but the percentage still remains considerably lower.
Okay. Yes. Yeah. Sorry.
Thank you. So, have you tried to culture cells that you receive in one media then in new one, try to standardize those cultures? Because if that is the problem, then are you trying to come up with a solution or not?
It's yelling at me, sorry. I didn't quite hear your question. Have we tried to transfer between media?
Yeah.
Yes.
Okay.
So, if a cell culture is deposited to us in not one of these systems, so we at WiCell, we are committed to culturing the cell forward in the system that it was deposited with us, to be respectful of the provider and how they like their cells to be. If it's deposited not in one of these systems, we will ask politely if we can switch to one of these systems so that there's more consistency within the bank. We can, in most cases, move cell lines between MEFs and feeder-independent or feeder-free systems. There have occasionally been cell lines within that 1,350 cell line collection that don't like to move, but they're rare.
So you've karyotyped thousands and thousands of lines and clones. Have you found any relationship between the way the cells are passage and the incidence of particular changes?
Not yet. We're looking hard. So our cytogenetics group has been doing a lot of work in the last few years looking at changes over time and how those might relate to culture systems. We have not yet been able to link them to any particular culture system, at least not to any medium matrix combination. There may be other aspects of the culture system like additives and things like that that we haven't looked at yet that may have some effect, or gas atmosphere concentrations or things like that. But to date, the abnormalities we see, particularly the 20 and the 1 issues that we see popping up, they occur across platform and across cell line. So.
And any relationship between sort of passage number and number of divisions?
Yeah, that's a really interesting question, and whether or not passage number is how we should be reporting it. We, in some cases in our new derivations, have been keeping track in terms of days in culture rather than passage number, which might be a more accurate representation of the age of the cell line. We have not seen, obviously the older the cells get, the more likely they are to accumulate mutations, but we've seen mutations in very young cells, and we've seen very old cell lines that are apparently normal. So,
another question, and clearly, it would be fantastic if a majority of labs could use the same medium, and we have a standard medium. And I don't think we are far from that because we start to have a lot of experience. And we have stem cell technology in the room today, but cost, you said cost effective, but cost is a clear challenge, I think.
yes. Yeah,
So
cost not only in media, but in the matrix as well. And if you're growing in low oxygen, that can start to add up over time as well, depending on whether you're generating it or whether you're buying it, how much tank rental costs, how much it is to maintain that kind of system to be able to deliver. So yeah, cost becomes a pretty intensive thing to deal with, yeah.
Martin?
Just mentioned low oxygen. I wonder if you just mentioned the low oxygen culture, and I gather your standard conditions are air, but have you any experience comparing genetic stability in low oxygen to air?
I haven't looked, I guess we did. So in the original work where we developed the teaser media, it was published in 2006, there's a section in the supplemental data that is all about the oxygen concentration, and it not only looked at maintenance of the undifferentiated state and cell expansion, but we also did karyotype as well. I don't remember noticing any differences in the low oxygen conditions in karyotype in the study that we did. We did see a tremendous advantage in both maintenance of the undifferentiated state and in cell expansion in low oxygen. Our problem was all that work was done in isolettes, where you opened it once a day, and it kept it very stable. When we tried to move that into the laboratory and do it in an open system, the tremendous flux that happened on a regular basis, opening and closing when you're doing large-scale culture, overwhelmed the advantage that we saw. So we moved away from it. But when we're doing very delicate experiments where we are having to individualize the cells, we will go into low oxygen on the day that we plate, and we tend to get better cloning efficiency of those single cells if they're cultured in low oxygen for the first day.